current memory systems actually make your agent dumber. Here's why. So right now, you probably know this. You turn the memory on in something like Claude and ChatGPT, your agent, whatever, and you see an improvement in the performance until you hit a peak, which is usually what the vendor will look at because they will want to tell you it's a great feature. But then after that peak, you actually have declining performance, and this is because of context rot. I have a separate video on context rot. It'll be somewhere on the screen. Feel free to check it out. But essentially, it means that there's too much context, and that context will mess with the attention of the LLM, which then will lead to a decay of performance and a degradation, and you'll actually end up with worse performance down here than you had before you even turned the memory on, right? So initially, everything's great. This is something we've seen with OpenClaw, for example, where at first people are like, it's amazing that it just has a fairly simple memory system. It's amazing that it remembers these things and it figures this shit out. And then at some point, it just, has collected so much cruft that it just gets dumber and gets worse at doing its job. And so this is the current state, right? And what we're trying to do, or, anyone that's building like a memory system, what they should try to do is to essentially have, of course, the same kind of peaking behavior, but then try to get a net gain where essentially we don't do harm, right? And so then we have at least net gain of performance and no degradation over time. And from our experience, so far, no one has really solved that. There's MEM0, there's tools to just build a memory layer into your product. But ultimately, we always see the same thing, that you end up with non-related retrieval, which bloats the context and gets worse performance. Right now, I think what you can do is to create a niched down version or a very specific solution for a specific memory problem. And that, I think, is possible to engineer because it is very unlikely that you will have this much context to get to context rot. And this is something we're working on right now as part of an internal, product we're building. But I can give you a concrete example, and this isn't necessarily exactly what we're doing, but it's a different use case. So I have a use case where I'm monitoring an inbox and I get invoices. And then for each invoice, I look at who's the sender of the invoice and who's the receiver of the invoice. And some of these invoices I want to automatically pay or want to forward them to get paid somewhere else. And I have a mixed inbox. So there's some personal invoices and then there's some company invoices, and I only want to surface the company invoices, right? And so this is a classic memory system where I want to tell AI to essentially only remember a certain, type of thing. So what we are building into the flow is essentially that the user can tell us, ignore invoices from, this and that vendor, for example, or this and that email that sends the invoice, right? And instead of throwing that into a memory tool that is generic and every time I write a message, it will try to extract, entities, which is what MEM0 is doing, right? So it's trying to extract what's being talked about, and then one of that is something that is worth keeping around as a memory, so then later we might want to pull it up, which is also what GPT and Claude is doing. But ultimately, so what we're doing in this scenario is essentially we're parsing out and we're creating, LLM call or whatever for a specific intent. And we say, okay, whenever the user says, I don't want any invoices paid to this vendor, we'll have a prompt, it runs and it tries to match the intent. And if it finds a blacklist of a vendor, that intent will be called. And then we save that maybe as structured data, right? So we do custom entity recognition of very important use cases. And because I know exactly what that is, what type of entity, I can always inject it, into whatever prompt I need it in, because I know exactly what it is, right? And so then I can say, okay, whenever you look at an invoice, part of the system prompt or whatever, however it's going to be orchestrated, will be these or the blacklisted vendors that we want to ignore. And then I just have a list of 10, 15, 20. I mean, over the lifetime, of course, you can have context rot again if they have thousands of vendors that they want to blacklist, but that is very unlikely. It's a much longer time horizon that will happen than it is if we will just use generic, memory solution. And so this is how you can enable proper and properly working memory for a specific use case. But of course, the trade-off here is that it's much less flexible, right? So if we have to find a custom built solution or workflow for each type of memory we want to have, that needs to be built, that needs to be thought through, which makes it perform better, but also makes it harder to build or more annoying to build, right? Because it's not just slapping on two calls to an API, but it's actually thinking about the issue, thinking about, is this really necessary to retain? Yes or no? And if it is necessary to retain, then how do I retain the least amount of data possible? And how do I inject it smartly into whenever I need that data in order to pass as little context as possible, but as much context as necessary, right? So this is kind of how you can think about it. And this is how we are trying to build a memory layer, but just for specific use cases or specific niches where we know exactly and we have a lot of control over the workflow. And I think for now, because this is a technical, restriction of LLMs or the architecture of LLMs with the context window, is the only way to get it working properly. And, it maybe won't look as cool in a demo, but it will be working better in a production use case. So yeah, let me know what you've tried to build out memory or any sort of similar features, and I'll see you in the next video. Cheers.